Hello, this is Mrs. Decker, and this is Unit 6, Objective 1A. I can define energy and differentiate between kinetic and potential energy. So before we get started, I want you to think about these two questions. What is energy, and what are some of the different forms of energy? So go ahead, take a minute, and jot a few things down. Now, most students can usually come up with a couple of different forms of energy, but the definition of energy is where we struggle. So I'm going to give you the definition that we will use for energy in this class. Energy is defined as the ability to do work, cause change, or produce heat. And work is defined in chemistry as a force acting over a distance. Now here are just a couple of different forms of energy. There are many more, but these are the most commonly used ones in chemistry. Chemical, mechanical, light, heat, electrical, and sound energy. And we don't want to just be able to name the forms of energy. We want to understand how processes change energy. So for example, photosynthesis takes light energy from the sun and turns it into chemical energy that is stored in the glucose molecules. A glow stick is a chemical reaction that happens in the glow stick, and that chemical energy is transferred into light energy that is transferred to its surroundings. Now, all of these different forms of energy fall into one of two categories: potential energy or kinetic energy. So let's first talk about potential energy. Potential energy is energy due to position or composition. So if you look here, a real-world example is chemical bonds. And the energy, the potential energy in chemical bonds, comes from the attractive and repulsive forces within a molecule. The formula for potential energy is mass times gravitational acceleration times height. Now, you won't have to calculate potential energy of an object, but you should be familiar with the equation. And if I ask you a question like, what has more potential energy, a mass with 25 kilograms versus a mass with 35 kilograms, you should be able to tell me that the mass with 35 kilograms will have more potential energy because of the greater mass. So our chemistry example is chemical bonds, and a real-world example is the energy that is stored in the food that we eat. Now, kinetic energy is the energy of an object due to its motion. All molecules are in motion, but some have more freedom depending on the state of matter. Even molecules within a solid are still moving, they're just moving very, very slowly and sort of vibrating back and forth. As we go from a solid to a liquid, the molecules have a little bit more freedom and move a little bit faster, and then as we move to a gas, the molecules have lots of freedom and are moving a lot faster. Our formula for kinetic energy is 1/2 mass times velocity squared. Our chemistry examples are hydrochloric acid and magnesium. So you have seen hydrochloric acid before in the lab. It looks like a clear liquid. So even if I have a beaker of hydrochloric acid sitting on the lab table, not being touched, the molecules are still constantly in motion even though we cannot see them, and that is kinetic energy. And a magnesium we have also used in a couple labs. It's a solid metal that is silver shiny, and even though it is a solid, the molecules within the magnesium are still moving very, very slightly. That is also kinetic energy. Our real-world example would be a student running laps. So on Google Classroom, there's a link for a YouTube video that has a song that explains the difference between kinetic and potential energy. So I want you to watch that and then work on the practice in pages 2 and 3 of your packet.